All right, so welcome back, class. And so what we've gone over so far is we've gone over basically um, we've gone over 10 different groups that we can install onto an aromatic ring. Bromine, chlorine, nitro, sulfonic acid, alkyl groups, and acyl groups. And then for some of these, we can take some of these groups and turn them into other functional groups. So I can take the nitro group and reduce the nitro group to an amine to make aniline. This is a reaction, this is the radical bromination. If I take this molecule, if I take an alkyl group, toluene, and I react it with an excess of NBS, which is a radical form of bromine, that's going to replace the hydrogens in the benzylic position with bromine. So that was from section 17.6. I can also take this toluene, this type of molecule with hydrogens in the benzylic position, do an oxidation to make the carboxylic acid, and then I can also reduce the carbonyl to go from the ketone or to the alkyl group. And what we want to now, so what we've been going over so far in all of these cases is going over the forward in all of these cases. So in all of these cases, we've really been focusing on how do we go from here to here. So now what we're going to think about is how do we figure out, how do we piece the steps together? How do we figure out what steps go together to make something? So these are retrosynthesis problems. So for example, how do we make meta-bromo-nitrobenzene from benzene? And again, when you have the di-substituted aromatic ring, when that's the product, you have to basically think about which one you want to install first, and that's based on the relationship between the two things. If the two groups are ortho to, or if the two groups are ortho or para to each other, you want to install an ortho-para director first, right? So the general rule here is if the groups are ortho or para, right? If the two groups you're trying to add are ortho slash para, add the ortho para first. Okay. If the two groups are meta, as they are above, right? Not meth, meta, you want to add the meta first. Okay? So when you look at these two groups, what you have to decide is which one's the which one's an ortho para director and which one's a meta director. So because the groups are meta to each other, the meta director needs to be added first. Bromine is an ortho para director, right? And the nitro group is an ortho para director. So you're going to put the nitro group on first, followed by the bromide. So in the forward, what that's going to look like, so again, the way I came up with that is like these two things are meta to each other. So in the forward, what you're going to want to do is you're going to start from benzene. Because the two groups are meta to each other, I'm going to do the nitration first because the nitro group is the ortho para director. So I'm going to put on the nitro group first. So that gives me nitrobenzene, and I'll put it just in the same position as it's drawn up there. And then I'm going to do the bromination. Because this is an ortho para director, I'm going to get predominantly the meta product here. So this is relatively simple when you have the di-substituted case, and you should be able to do tri-substituted and maybe even tetra-substituted, but we're going to go over di-substituted situations right now. So when I have this situation, right, the two things are meta to each other, so the meta group has to go on first. One thing to think about is you can change the directing group of some of these substituents by using some of the reactions where we can do the via functional group conversion. So for example, the nitro group is ortho para director, so that's going to, the nitro group is meta directing, so it's directing here and here. The aniline, the NH2 is ortho para directing, so it's going here and here. Now this is such a strong ortho para director that it usually will just, boom, add everywhere. Again, alkyl group, ortho para directing, but if I oxidize to the carboxylic acid, that's meta directing. So see how we've changed the directing a group, the directing effect of the whatever's added on. So the ketone is meta-directing, but the alkyl group is ortho-para-directing. And again, this alkyl group here is ortho-para-directing. If I make the carboxyl, if I add the halogens on here, all of a sudden I get a meta-director on. And the reason this becomes important is because if I look at a molecule like this is ortho-para-directing, this is ortho-para-directing. And the two groups are meta to each other. So if they're meta to each other, but the groups themselves are ortho, and if neither of the groups are meta-directors, what that means is that you have to basically make something a meta-director and then turn that into whatever group you want. So for example, based on what we know now, like in the previous slide, this is an ortho-para-director, this is an ortho-para-director. So I can't put either of them on because these two things are meta. But I know from the previous slide, right, that I can make the aniline from a nitro group, right? So if I kind of think about this, I kind of think about, well, and I can, if I had this molecule here, I could turn the chloronitrobenzene into the aniline compound. Well, now these two things are meta to each other. This is a meta-director. This is an ortho-para-director. So now I think, well, I can make I can put those two things meta to each other if I had this compound, and then I know how to nitrate benzene. Okay? So in the forward, what I would have here is I would start with benzene. I'm going to do the nitration. So sulfuric, so that should be a 3. I'm going to go ahead and change that into a 3. Sulfuric acid. That's going to put the nitro group on. Okay. And then I'm going to do the chlorination. That's going to put the chlorine meta. And then I'm going to reduce, and it's a 2-step process. So it's zinc followed by, I think, sodium hydroxide. And that is going to reduce the nitro group to an NH2. And that leaves the chlorine alone. So that's the forward, right? And the way I came up with that process was understanding that these two groups are meta to each other, but neither of these are meta directors. But I can get one of these groups from a meta director. So again, this is the kind of the overall sequence. I do the nitration followed by, so this is showing you how you get from here to here, okay? So this is the overall sequence that we just went over. And one of the things that to think about is when you have this molecule here, there's a couple of caveats. There's some limitations when you're planning synthesis. One of the limitations is I can't do the nitration with an amino group. So this is called an amino group. So the NH2 is known as an amino group. I can't do the nitration with an amino group because these conditions are oxidizing, and that will oxidize the amino group to the nitro group. Another thing to keep in mind is that I can't do Friedel-Crafts reactions when I have a moderate to strong deactivator on the ring. So for example, this is a moderate deactivator. This is moderately deactivating. This is a strong deactivator. So when I try to do the Friedel-Crafts reaction, whether it's Friedel-Crafts alkylation or Friedel-Crafts acylation, these reactions are not viable. All right, so try to practice trying to figure out how do you come up with di-substituted molecules, and maybe something to think about is, you know, how you might start making something like a tri-substituted molecule, right? So for example, a problem to maybe think about doing is how, let me see if I can come up with a problem for you to work on, you know, just on to practice. So maybe let's say you're trying to, like, how would you go about making something, like what would be the most efficient route to make something like this. So think about what would be the most efficient route to make something like this starting from benzene, okay? And then maybe come up with questions for that, and then I can go over that maybe during one of the discussion sections. All right, so that's synthesis strategies. Let me know if you have any questions. I hope that made some sense, and I will talk to you later.